Pancholi, Assistant Professor in LG Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject fiber optic communication. So friends, till now we learned about the basic fundamentals related to the fiber optic communication. Specifically, in this video, we are going to learn about the optical fibers substructure, waveguiding and the fabrication. In this video, you will learn about the various optical laws and the definition. We will also learn about the refraction. Friends, you know that what is a refraction? When the homogeneous medium is there for the traveling of the incident wave, then the reflection would occur. But when the light ray will pass from the one medium to another medium, the another component or the another aspects we need to study, it is referred to as a refraction. So what is a refraction? What are the refraction laws and about the examples related to refraction that we need to study over here. So we are going to start with the refraction. Here you can see that the naturally how the refraction would occur. So refraction at a plane surface. Now what is the refraction? Here you can see in the diagram we have a light source. So the light from the light source will pass. So we say that it's an incident light or a ray. So now it passing from the air medium to, here you can see that, the glass. So when the light will pass from the air medium to the glass medium, so at that time the bending of the light that would occur, and this bending of the light would occur, it is referred to as a refraction. So you can see over here in the diagram how the refraction would occur. So the definition is when the light ray travels from the one medium, that is the air, to the another medium, suppose it's a glass, then the bending of the light ray takes place and it is referred to as a refraction. Here in the diagram we can see that is the incident ray, okay, and the incident ray, okay, that will passing from the one medium, that's the medium number 1, to the medium number 2, okay. So the incident ray will make an angle with the normal axis, it is referred to as an angle of incidence. And when it passes from the one medium to the another medium, the refraction would occur, and the refracted ray and the normal axis, the angle which is made, it is referred to as an angle of refraction. Here you can see that the 90-degree angle also. So this way the refraction that would occur. So when the light ray travels from the air to water, then the refracted ray bends toward the normal. So when it passing from the air medium, okay, air medium, the lesser density, okay, less refractive index, and when it pass through the water, that is the higher refractive index, higher optical density, okay, then what happened? The refracted ray that bends towards the normal axis, okay. So it is the laws, okay, important thing related to the refraction. Now if the light ray enters the another medium perpendicular to the boundary, then at that time the ray that will not bend. So ray does not bend in this situation. So the refraction, okay, in that when the light travels from the water to air means higher density medium to the lesser density medium, the refracted wave that goes away from the normal. So here you can see in the diagram we have a two medium. One medium, that's the air medium, another medium, that's a water medium. So when the light will pass from the water medium to the air medium, what happened? The refracted ray will go away from the normal axis. So it is what? It is a refraction. So during the refraction, the light band first on passing from the air to glass and again on passing from the glass to the air. So when it changes the medium, what will happen? Here you can see that the incident ray passing from the air medium, it travels to the denser medium and again from the denser to the rarer medium. Okay, so we can see in the diagram the incident ray, okay, will make the angle with the normal, that is the angle of incidence. Fine. Now when it passing from the air medium to the water medium, okay, you can see that the refracted ray as well as when it passing from the glass medium to the air medium, okay, again the refracted ray that goes away as well as towards the normal axis. So during the refraction, the light band first on passing from the air to glass and glass to air. So light speed ups when it enters an optically less dense medium, and the refracted ray that bends away from the normal when the second medium is optically less dense. As we know that when the optically denser medium, okay, higher density is there, the light speed that becomes less. Okay, so refracted bands that away from the normal axis when the second medium, that is optically less dense medium. Okay, so while we are listening about we are studying about the refraction fundamentals, it is a very important thing. So here in the diagram you can see that the incident ray passing from the water medium, okay, now when it enters to the less density medium, it's an air medium, you can see that it goes away from the normal axis. Similar diagram you can see over here, that here the paper with the fine sand, okay, what happened? That while the incident ray, okay, that will pass from this kind of the medium and then it enters to the wedge, okay, what happened? That it goes away, okay, from the normal axis. So normally there are the three transparent medium: air medium, water medium and the glass medium. And out of these three, the glass that has the highest optical density. Okay, so here is the three things we can see simultaneously. While the optical ray will change the medium from the air to water to glass, mean air having the lesser density, okay, medium and the higher. Similarly, here you can see the opposite thing, that is what happened, that the while it will change the medium, okay, that is from the water, the glass, water and the air. So incident ray, okay, in the first diagram we make an angle that is the I1. Air medium, lesser density. Water medium, okay. So now the water having the comparatively the higher one, okay. So what happened? Here you can see that the R1, okay, that is the angle of refraction. Similarly, over here the R2, that is again the angle of refraction. Okay, similar way here you can see that while passing from the glass to water to air, how the refracted ray that goes away from the normal axis as well as it goes near the axis. So now here we have a various law of refraction. So the law number one is the incident ray, the refracted ray and the normal at the point of incidence. They all are in the same plane. So they all are in the same plane, all angles. Law number two is for the two given media, the ratio, it's a sine I. I is the angle of incidence and R is the angle of the refraction. So it's a constant one. Okay, so we can say that what is the refractive index? Refractive index, it is the sine I upon sine R. Okay, so sine I upon sine R. So here you can see that what is the I angle? Angle of incidence, incident angle. Okay, and refracted ray. The higher the optical density, the greater the refractive index. And greater the refractive index, the greater the bending of the light towards the normal. Okay, so here again the same thing you can justify. Okay, that how the higher the refractive index, okay, and how the light, okay, that will be emitted, okay, so that refracted light, okay, you can see in this diagram. So if the incident light, you can always start the example. So example, if the light is incident upon a piece of a glass, refractive index, okay, that's a 1.52 at an angle of 45 degree. What is the angle of refraction? So we know that the formula of the refractive index, it is eta is equal to sine I upon the sine R. Okay, so it is the 1.52 refractive index is given. Okay, so it is the sine 45 upon sine R. So sine R is sine 45 divided by the 1.52. Okay, and the angle of refraction you will get, it is the 27.7 degree. The another example we'll do, it's a write down everyone. It is given that the refractive index of the water is 1.33. Calculate the angle of refraction when the incident ray comes in at 60 degree to the normal. Okay, so it is the example. Now we'll do the solution of that. What is the refractive index equation? It is eta is equal to sine I upon sine R. What is the refractive index given over here? 1.33. So put that value in the equation. Sine I angle of incidence is given to us. It's a 60 degree. So we'll put that 60 degree over here. It is divided by the sine R. So sine R is equal to sine 60 degree divided by 1.33. So R angle of refraction, it is 40.6 degree. So this is about the another example. So the important things to remember that when the light travels from a less dense medium to the denser medium, okay, the refractive index is always sine I upon sine R. Okay, so less dense medium to the higher density medium, mean from air to water. The equation of the sine eta is equal to sine I upon sine R. But the reverse thing would happen. That is, when the light travels from a denser medium to the less dense medium, the refractive index eta is equal to sine R upon sine I. Okay, so water to air, okay, the equation is sine R upon sine I. So now let us solve the example. The figure shows that the light traveling from the water to air. Okay, water to air means higher density to the lower density. The ray is incident upon the boundary at 30 degree. What is the angle of refraction if the refractive index of water is 1.33? So you can see the example. What is the equation of the refractive index when from higher to lower? Okay, it is sine R upon sine I. So what is the refractive index of the water given? It is a 1.33 is equal to sine R upon sine 30. So sine R is equal to 1.33 multiplied by sine 30 and it is 41.9 degree. So this way, by drawing the diagram like this or by considering from where the incident ray, okay, that falls upon the another medium. So this way you can get the idea. So other ways of calculating the refractive index, that is what? So here you can see that the diagram, okay, the air medium, the water medium. Okay, the normal axis you can see over here. So now how the ray, okay, that bends, okay, as they can pass through the particular the boundary. So you can find out the real depth, okay, divided by the apparent depth. Okay, so when you will see from your eye, you can see the two difference, okay, and from that you can also find it out the refractive index. So what's the definition of the refractive index? It is the speed of the light in the vacuum or the air divided by the speed of the light in the particular medium. So speed of the light, we can mention it by writing the c divided by the speed of the light in the medium. That's a v. So this way we can find it out the refractive index, okay, for the particular thing. Okay, so this is about the refraction, examples of that. So thank you very much everyone.